Hi everybody, and welcome to lesson 2.2. Today we are going to start on page 18 of our book, and you're going to want a pencil, a highlighter, and probably your vocabulary list handy for these activity 2 words because it's a pretty vocab heavy lesson we have going on today. Now before we start on page 18, what I want to chat with you about is a story about good old John Doe. And John Doe, he likes to go every morning to the local store to get a coffee at 7 a.m. And one day that store is robbed at 7 a.m. Is this proof that John Doe robbed the store? Now, you're probably saying to yourself, no, that's not necessarily proof. He could have just been one of the people that were in the store when it was robbed. Or you might say, okay, John Doe was the one that did it. The reason that this kind of situation is important is because it leads us into the idea of deductive reasoning. We cannot just assume a conjecture is true with our inductive reasoning, and we saw that in the last lesson. And we can't assume John Doe is the one that is holding up this local store in this robbery just because he's there. We need to prove it. So in order to make things proven, we have to go through an argument. Now, this isn't just like a disagreement with another person argument like you see over here. It's logical reasoning through what we call a proof. So the process of deductive reasoning isn't just observing the patterns, it's coming up with proof as to why this is true. Once you come up with that proof, those logical steps, then our conjecture becomes a theorem. So a really, really, really important paragraph here in red that you're going to want to read through. So like I said, what I like to think about is in order for a conjecture that we talked about in the previous lesson to become a theorem, without a doubt true, that process right here, this is the proof that we have to go through. Okay. Now, we're actually going to jump ahead a couple of pages. We're going to go all the way over here to page 22, and we're going to talk about together numbers 12 and 13. Now, on page 22, the first box here says that we want to compare and contrast a theorem and a conjecture. So again, our conjecture is what we talked about in the previous lesson, 2.1, and that's going to be involving inductive reasoning, right? That's our inductive reasoning because a conjecture is just based on the observation or patterns that may or may not be true. A theorem, on the other hand, if we look here, a theorem is from this current lesson of 2.2, and that's going to be based on instead the deductive reasoning. Okay, and that the theorem then is that it's a conjecture that we prove to be true using logical facts and reasoning that we also know are true. Okay, so there's the difference. Now, number 13 says that Todd knows that 3, 5, 7, and 11 are prime numbers. Based on this evidence, he concludes that all prime numbers are odd. Is this an example of inductive or deductive reasoning? Well, this is going to be an example of inductive reasoning because it's a conjecture. It's just based on several prime numbers, but not proving it for all of them. So it's just a conjecture, so it's inductive. If he had proven it for everything, then it would have been deductive. Now, are we able to say that his conclusion is correct? Well, we're going to say no, because 2 is an even number that's not prime. Or excuse me, that is prime, but it's an even number. So his conjecture was not true. All right, now I'm going to have you guys try number 14 on your own. All right, last but not least, something that we are going to see that is really popular that you've already done in your life is algebra proof. So this is just like an extra example that you're going to want to write down. But just a reminder, think about your algebra classes last year. Let's say that you had the problem 2x minus 12 equals 8. okay? And you want to prove that x equals 10 is what you're trying to say. Is this true or not? Well, think about what you would do in those classes. The first thing you did last year is that you would probably say, okay, I'm going to add 12 to both sides. Why am I allowed to now say that 2x equals 20? Well, this was all possible by the addition property. Okay, we know that we are allowed to add that to both sides of our equation because of addition property. And then the next thing you would hopefully think to do is to divide by this 2, right? We know we want to do some division to both sides to get our value of x by itself so that we could prove that this worked out, okay? We know we're allowed to do these because of the rules of arithmetic and algebra, okay? This is going to lead us into our next lesson as well. I just wanted to throw it in there to get your minds thinking of where we're going with this. Thanks, everyone.